Okay, Algebra 2 students, we are going to graph square root functions and cube root functions. So the parent function, it can be formed from a table of values. If y is equal to the square root of x, then you can plug in certain values for x. So I can't do the square root of a negative number. The first number I can do the square root of is 0. So if you're building a table of values, you could put 0 in for your x, and the square root of 0 is 0. The square root of 1 is 1. And I don't want to plug in 2 or 3 because those square roots are irrational, but I do know that the square root of 4 is 2, so I can plug in a 4 and I get out a 2. And then again, 5, 6, 7, 8, those square roots are all irrational, but I can do the square root of 9 and that gives me 3. So these are the points that you see here, 0, 0, 1, 1, 4, 2, 9, 3. These are formed from the table of values, and that's for your parent function, y is equal to the square root of x. So you can transform this function just like you've transformed other functions like quadratic equations. If you have a minus inside the function, then that's going to do the opposite. The minus would actually shift right. So if you have a plus, that's going to shift left. So shift left 4, and then outside of the function is a plus 1. That's going to shift up 1. So literally this whole parabola is picked up and shifted left 4 and up 1. And the method I use is I start with the start point here. This is an arrow, and then this is an end point. So I'm going to take that point from 0, 0 and move it left 4 and up 1. And then I follow the same pattern that I had here. From the start point, go over 1 and up 1. Over 1 and up 1. And then from the start point, go over 4 and up 2. Over 4 and up 2. And then go back to the start point and you go over 9 and up 3. Over 9 and up 1, 2, 3. And then you're going to draw in the curve. Okay, let's go to the next one. You use the same parent function, this one, for all of your square root functions. So the next one, we're going to take this parent function and we're going to shift it down 2. So pause the video and see if you can do that. Pick up your start point and shift it down 2. And then from the start point, you're going to build your parabola. Not your parabola, but your square root function. Okay, so you've paused the video and you drew your function. Let's see if you did it correctly. The first one is down 2. Now from there, you want to build your square root. So you're going to go over 1 and up 1. Go back to the start and go over 4 and up 2. And then lastly, you want to go over 9 and up 3 and graph that. Okay, now I'm going to show you also how you can do this on the calculator in case you get confused. Okay, so say we wanted to check our answer to this question here. Press the y equals button, and the square root is above the x squared, so you press second and x squared. That's your square root. Plug in the x. And because the minus 2 is outside the square root, you need to close the parentheses and minus 2. And so you'll hit graph, and you'll see a graph. If you do zoom, you can go to your standard window, 6. And that looks a lot like what we have, but if you want to double check that your points are in the right place, you press second table. See all these errors? That means that there's no points over there where the x values are negative. So the first one you have is 0, negative 2. So you would plot 0, negative 2, and then you have 1, negative 1. So 1, negative 1, and then you scroll down to get some more points. Okay, so 4, 0, that is right here, and keep scrolling down, and you get 9, 1, and that's this point right here. Okay, so let's try this next one by hand, and you can also try it by the calculator. Okay. So I look like I'm moving left 2 and up 3. So my start point goes left 2 and up 3. Now this negative means that it's flipped vertically this way. So instead of making a rainbow, it's going to make an upside down rainbow. So normally I would go over 1 and up 1, but because of the negative, the flip, I'm going to go over 1 and down 1. And normally I would go over 4 and up 2, but I'm going to go over 4 and down 2. And then I'm going to go over 9 and down 3. So my square root function flipped upside down. Okay, let's turn the page. All right, here's an example of a square root function with a vertical stretch. Okay, so that means only the y values were stretched. Remember your parent function is 0, 0, 1, 1, 4, 2, 9, 3. That was your parent function. But everything is being stretched by 2 vertically. So you still go over 1, but you go up twice as high. You still go over 4, but you go up twice as high. So 2 times 2 gives you 4. And you still go over 9, but when you go up twice as high, normally you went up 3, so 2 times 3 is 6. So in this one, we're graphing y equals 3 square root of x, so we're going to stretch by 3. Vertical stretch of 3. So 3 times 0 is still 0. That start point didn't change. When you go over 1, instead of going up 1, you go up 3 times as much, so you go up 3. When you go over 4, instead of going up 2, you go up 3 times 2, so you go up 6. And when you go over 9, instead of going up 3, you go over 3 times 3, so you're going to go up 9. So over 9 and up 9. And this is your square root function with a vertical stretch of 3. All right, so we're going to do a cube root function next, and let's look at the parent function for the cube root function. This is also built from a table of values, but you can do the cube root of negative numbers. The cube root of negative 8 is negative 2. So again, you make a table of values, you plug in some numbers, like you know the cube root of 0 is 0, and the cube root of 1 is 1, and the cube root of negative 1 is negative 1. And then you want to think of some bigger numbers. I don't know the cube root of any of these numbers because they're irrational, but the cube root of 8 is 2 because 2 times 2 times 2 would give you 8. And then the cube root of negative 8 is negative 2. So if you plot these points, it would give you this graph, including this one here in the middle. So let's see if we can shift this graph around a little bit. Okay. Just like the square root function, inside of the function, if you see a minus 2, that's going to move you right 2. And a minus 1 is going to go down 1. So you want to start with the center point, this one. And I'm going to move that center point right 2 and down 1. From there, you would go over 1 and up 1. You would go left 1 and down 1. So right 1, up 1, left 1, down 1. And from the center point, you go right 8 and up 2. So from the center point, go right 8 and up 2. And from the center point, go left 8 and down 2. Okay, and the last one has 2 shifts and a stretch. So we're going to go left 1 and down 1. And we're going to do a vertical stretch of 2. So your center point from this parent graph is left 1, down 1. Then the parent would normally go over 1 to the right and up 1, but we're going to go up twice as much, so we're going to go up 2. So 1 to the right and up 2. 1 to the left and down 2. And then you're going to go 8 to the right. Normally you would go up 2, but you need to go up twice as much, so we're going to go up 4. So from the center point, go 8 to the right and go up 1, 2, 3, 4. Go to your center point, go 8 to the left and down 4. And sketch your point graph in. Now, if you're not sure if you got your points in the right spot, check it with the graphing calculator. So let's plug this one in. Okay, so type 2. Cube root is in the math button, so press math and it's choice 4. Cube root x plus 1. Close your parentheses and then a minus 1. And then press second graph to look at the table of values. So my table of values, I'm expecting a point over here at -9. So I'm going all the way back to -9. All right, so I have a point at -9, -5. And then I'm going to skip over these because those are all rounded values. And I have a point at -2, -3. And -1, -1. And if you keep scrolling through, you should get all of these points as well. Okay, so that's the end of your note.